Okay, in this lesson we're going to continue our discussion about simplifying rational expressions, but you can see that this problem got longer and there's multiplication happening here. Well, multiplication with fractions is nice because really it just continues the bar, and the top's still being multiplied next to each other and the bottom's multiplied next to each other. So basically you could imagine the whole thing's just squished together. And what's nice about that is that the things that are on the top can cancel out with things that are on the bottom, whether they're diagonal, like this x plus 2 can cancel out with this x plus 2. And so you can cross cancel, if you will, if you've heard that before. And so that's what I'm going to do. But first I'm going to take a look at what x can't be. And we said before that on the last lesson that x can't, or the bottom can't be equal to 0. So we set each one of these bottoms equal to 0 and show that x can't be -3, it can't be 2, it can't be -2, and it can't be -1. So there's 4 things that x can't be that you would probably put into your solution if you were asked about the domain here. Okay? So I'm going to go ahead and erase that and get back to canceling. So I'm going to look at my x plus 2 and I'm going to cancel out with this x plus 2. You can cross cancel. And then I'm going to take my x plus 1s and cancel them. I'm going to take my x plus 3s and cancel them. So this problem actually just turns out to be an x plus 4 on top and an x minus 2 on the bottom, and you've got your simplified solution. And then of course you should go back through and say that x can't be -3, +2, -2, and +1. But this is your simplified solution. So you just cross cancel and reduce as much as possible. So let's take a look at this problem. This problem's not quite as nice and ready to go because if you notice the last problem, everything was a factor. This one needs to be factored to make that happen. So I actually have to factor 4 times, 4 places, 1, 2, 3, 4, if possible. So I look to factor 4 times. And that's usually what I say in my notes is my first step is to factor 4 times. Okay? So on the top left, you can see they both have a 5 in common. If I factor out a 5, you'd get p minus 1. Now on the bottom, you can't factor a p, it's just p. On the bottom right, you see they both have a 10, and then you're left with p minus 1. And then on the top, there's nothing to factor out of a 3p squared. So I'll rewrite it, and we've got 5p minus 1 over p times 3p squared over 10p minus 1. Now this is the step where you should check for, once you've done your factoring, check for your domain. So step 2 would see what can't x be, so x can't equal what. Okay, and so right here I would say that, well, I can't put a 0 in for p, so p can't be 0. I'll just put it up top, so p can't be 0. And then over here, if I put a 1 in there, that would make that 0, so p can't also equal +1. So those are just domain issues. Okay, so now I want to go ahead and cross cancel. Oh, I lost my parentheses here. I want to cross cancel. Notice they both have a p minus 1. So I'm going to cross cancel those, and they're gone. And then also the 5 can reduce with the 10. So reduce that to be a 1 and a 2. And then you have p here, and you have 2 of them on top, so I'm going to cancel out one of the ones on top with the one on the bottom. And now I'm just left with 3p on top over the 2. And I've canceled out everything else, so that's all that's left. You can see the 3p and the 2. So that's where I got that solution. And again, p can't be 0 or 1. Okay, so it's just factor, figure out what x can't be, and then step 3 would be cross cancel. And step 4 would be reduce if you had to reduce. Okay, so factor 4 times, see what x can't be, cross cancel, reduce. Okay, and that's going to be the same process we're going to do here, even though it looks even worse. So we're going to factor 4 times, okay, and we factor these ones using the magic x. Okay, but what I'm going to do for time's sake is I'm going to go ahead and just factor them and give you the answers, and I'm going to leave it to you to factor using the magic x off to the side. And if you do that off to the side, you'll see that you would get these answers from the magic x. And now what you see is the top left is now turned into k plus 5 times k minus 3. The bottom is k minus 3 times k minus 1. And the top right is k times k minus 1. It just had a GCF. The other three were magic x. And then k plus 5 times k minus 4. So I rewrote it so that way you can just see it's a little bit more crisp to do my cross-canceling. But before I do my cross-canceling, I should say that x can't be, if you look at the bottom, it can't be 3, it can't be 1, it can't be negative 5, and finally it can't be 4. So now that I've done that, I'm going to go ahead and start canceling things. The k plus 5s will cancel, the k minus 1s will cancel, the k minus 3s will cancel. So all you're left with, in the end, is a k on top over k minus 4. And that is your simplified expression. So again, it's the same 4 steps I had before. We factored 4 times. We checked our restrictions, in other words the domain, and then we cross-canceled and reduced. And now here's a little bit simpler problem. The top left, still we're doing the same 4 steps. Step 1 is to factor 4 times. And in doing that, I'm seeing here, this is going to be difference of squares. So I'm going to write a plus 1, a minus 1. Now, I look for the other 4. There's nothing to factor here, nothing to factor here, nothing there. So now I just rewrite it. Actually, I can go ahead and state my restrictions. X can't be. X can't be here. If I plugged in a 0, that would be an issue. And also, if I plugged in a 1, that would be an issue there. So now I'm going to go ahead and rewrite it so that I can cross-cancel. So then I got a plus 1 times a minus 1 over 4a times 2 over 1 minus a. Now, what you'll notice here is that I can cross out the 4 and the 2 reduce to be 1 and a 2. But then nothing else appears at first to reduce. But this 1 minus a looks a lot like this a minus 1. And it actually can be if I factor out or change this by factoring out a negative. If I factor out a negative, that'll turn into negative 1 positive a. In other words, negative times a minus 1. Now they are the same thing, except there's a negative sign. So I cross out the a minus 1, and that leaves me with a negative 1 on the bottom. Don't lose that negative 1. And now I go ahead and multiply straight across and write what's left. And I'm left with a plus 1 on top over, there's a 2a, and there's a negative sign, so I put the negative out in front. And that is my simplified answer for this problem. And finally, we're going to look at the worst looking problem you've probably ever seen in your life. And if you just if you take that problem in for a little bit, you'll probably scare yourself. But this is actually like one that we've already done. The thing that gets scary, or appears to be scary, is the division sign. But the thing with whenever you divide by a fraction, you're supposed to flip and multiply, which means you take the second fraction, the one that's on the denominator, that's actually you're dividing by, and you flip it. Okay, so we're actually going to rewrite this with this fraction flipped over. Now, before I flip it over, I want to go ahead and factor it because there's no sense flipping it and factoring it and wasting a lot of space. So I'm going to factor it first. I'm going to write all the factors on top and bottom, and then I'll flip it. So let me factor them. Factor using the magic X and write parentheses. So each one of these is going to get parentheses. Okay, for the sake of time, I went ahead and worked out the magic X for each one of these problems. You can see this is the top left. This is the top right. This would be the bottom left, and this would be the bottom right. So if you want to work them out and then check your work, just push pause on this and then you can work them through. I'm going to go ahead and erase. Okay, so now that I've erased, you can see that I've factored the top, factored the bottom. Now I can't cancel stuff because this is still division. So what I need to do is flip and multiply, which means rewrite the problem to be m plus 4 times 5m minus 3 over m plus 4 times 3m minus 5, and you flip the second fraction to be multiplication. So you flip and multiply, which means I rewrite this to be 3m minus 5 times 5m minus 3 over 5m minus 3 times m plus 1. Okay. Now I could have actually done some reducing before I flipped and multiplied, but it's alright. So I flipped it over, and now I can start canceling things. I should probably tell what my restrictions are. I should say that m can't equal negative 4, 5/3, 3/5, and then negative 1. Of course, respectively for each one of these, 1, 2, 3, 4, and that gave me this 1, 2, 3, 4 on the top. So that's where each one of those came from. And then I go ahead and just cancel. Okay, the m plus 4s can cross out. The 5m minus 3s can cancel out. So that's my vertical canceling. And then I can go ahead and cross cancel. The 3m minus 5s cancel. And all that's left is just 5m minus 3 over m plus 1. So for such a scary beginning of this problem, and a lot of magic X factoring, as soon as you flip and multiply, things start canceling magically, and you end up with this nice small answer like all the other problems. So hopefully I didn't scare you away too bad with this problem, but you do have one like this in your homework. So go through the 4 steps, factor 4 times. If it asks you about the domain, check for the domain. Then you flip, then check for the domain, and then cross cancel and reduce.